Hello, my name is Guang O, and I'm majoring in aerospace engineering.
My name is Jackson Motley, and I am majoring in mechanical engineering. Our honors project is called Wire Arc Additive Manufacturing of Metallic Materials.
And we are working together under Dr. Tuhin Mukherjee from the Mechanical Engineering Department for this research project.
To understand the scope of our project, it is first important to understand what additive manufacturing, and by extension, wire arc additive manufacturing, is. Additive manufacturing is a fairly common production practice where parts are created through the precise deposition of materials in thin layers. Multiple layers built up on themselves lead to the creation of a highly precise product. Examples of additive manufacturing are filament and resin-based 3D printers, which are very common hobby production methods. Wire arc additive manufacturing, or WAM, is a type of additive manufacturing that utilizes electrical currents to deposit a chosen metallic material in a precise manner.
To further expand the knowledge about wire arc additive manufacturing, let's go over the advantages and the disadvantages of WAM. The process is highly material and energy efficient, leading to minimal waste. The process is also highly precise, leading for its use when manufacturing low-tolerance products. The process is also very time-effective, allowing to the rapid production of large parts. Wire additive manufacturing is also highly cost-effective when compared to other typical production methods for individual parts. In contrast, some disadvantages of wire additive manufacturing include high thermal distortion, as well as low dimensional accuracy for production parts. There are also certain design considerations that must be accounted for when producing with WAM. Lengthening product's design time. Limitation on complex geometry also limits the wide-scale use of wire additive manufacturing.
A major problem faced when producing with wire arc additive manufacturing, and the problem we have been focusing on for the duration of our research, is called humping. Humping is a production defect that will negatively impact several aspects of a quality of a product. A product with the humping defect can be seen on the bottom left of this slide. As you can see, the inconsistent layer on top seems to jump up and down, similar to the humps of a camel's back. The negative impacts of humping range from a loss in dimensional accuracy, geometric quality, part strength, fatigue life, and surface finish.
The method we choose to solve the humping problem revolves around optimizing process parameters. In a research article called "A Methodology in Parameterized Wire Additive Manufacturing: A Case Study for Wall Quality Analysis," it was found that by adjusting parameters such as arc current and deposition rate, that certain parameters combination can lead to a decrease in humping, and as such improve the surface finish of the product. An example of this can be seen on the right of the slide. A proper combination of a 180 amps current and a deposition rate of 8 millimeters per second produce the best quality surface finish. Another method we are planning on researching is to utilize the oscillation during production. This process would involve the quick rotation and movement of the deposition arm to distribute the heat more evenly across the substrate.
To conduct our research project, we had the opportunity to work with the Vectis Cobot welding tool. This was a wire arc additive manufacturing machine purchased by Iowa State University from Vectis Automation in Colorado. The Vectis Cobot welding tool is 25 to 40% cheaper than the all-in cost, as advertised by Vectis. Another key benefit for choosing to study the Vectis Cobot is that no previous programming experience is required to operate the machine. Also, extensive safety features allow for the safe operation while still allowing for easy access to work on the machine without placing or removing any permanent barriers. Finally, this machine is compact and portable, which benefited our group when we had to move the entire machine out of a room that did not pass the proper fire inspections.
One of the first and most important steps in conducting our research was reading and understanding the Vectic Cobot's user manual. Outlined within the manual were several important details that would guide our research. Important safety hazards and information such as proper personal protective equipment, hazard warning, and emergency procedure. Description and instruction on several advanced features, such as stitch welding, both the basic and dynamic pattern tool. Touch sense. Oscillation could be the key tools to utilize when conducting our research. So it was very important we were familiar with them. The more basic function of the Vectic cobots were also outlined within this manual and hold equal importance to our research. To ensure the Vectic cobot is running at peak performance, maintains longevity, and remains clean, the general maintenance outline proper cleaning techniques and use. One of the first steps in setting up the Vectic cobot include calibration of the machine, outlining tests and fixes on several components of the cobot machine. This process ensures the cobot is operating at optimal accuracy. The troubleshooting section outlines several common issues users may face when operating the Vectic cobot and provides helpful feedback and suggestions on several problems. This ensures we are able to maintain operational efficiency when conducting research.
Important scientific information to keep in mind while conducting our research on wire arc additive manufacturing of metallic materials shaped our goals and procedures. First and most importantly, we needed to consider that wire arc additive manufacturing is a process often used to produce or repair precise parts using metallic material. This meant our research outcome could not solve humping while compromising the precision or accuracy of the overall additive manufacturing process. Another key piece of information is that wire arc additive manufacturing is often used for production within aerospace and mechanical engineering contexts. This was an important fact for our group, as the processes and information gained during this research project could be applied to our own majors and engineering fields of interest. Lastly, it was important for us to understand that wire arc additive manufacturing requires precise control over several production parameters. This knowledge guided our decision-making process, as we were then able to deduce what parameters to adjust in order to reach our desired outcome, that being a reduction of humping when producing a part with wire arc additive manufacturing of metallic materials.
For our future research plans, which have individual ideas and goals, I'm planning on continuing research under Dr. Mukherjee over the upcoming summer and fall semester. This is a great opportunity for me to enhance my knowledge as well as experience with wire arc additive manufacturing and to get a deeper understanding of the research.
I have great interest in continuing research under Dr. Mukherjee as well, and I plan on taking up an independent study course with him next fall semester. I also intend on using this information and experience I've gained while researching to explore opportunities at local material engineering firms this summer while I am home in Wisconsin.
While conducting our research in the future, we will be furthering our understanding of how arc current, feed rate, travel speed, and oscillation can reduce humping and improve surface finish in a controlled manner.
Our group feels an important takeaway from the first year Honors Mentor Program is the fact that we have made a connection to Dr. Mukherjee. This network will no doubt set us up for success down the road. Some personal key takeaways I have from conducting this research include our research outcome. Knowing that a possible increase in feed rate and arc current can reduce humping will be an important step in furthering our upcoming research. The introduction to the mechanical engineering field and a full research experience will no doubt guide my future decisions on what I'd like to do for my career. Lastly, I have seen several real-world connections to my Materials Engineering 273 course, which has been an important way to connect coursework with real-world experience.
And my personal key takeaway for this research project is to have the opportunity to gain experience on hands-on project, including the assembly of the wire arc additive manufacturing machine. And beside that, the first year honors mentor program provided me a handful of experience in the engineering field. And finally, I can also find connection in knowledge and coursework with many of my aerospace engineering courses, including Aerospace Engineering 160 and 161.
Thank you.
Thank you very much.